Hey, all, today we're going to talk about congruent triangles some more, and this time we're going to talk about triangle congruence theorems. So ways to show that two triangles are congruent without knowing everything about them. So make sure you add this to your flip book, the angle-angle-side theorem. Remember, a theorem is something that somewhere along the way somebody proved or showed to be true all the time. So if you look at these two triangles, I have angle A and angle F congruent. I have angle C and angle D congruent. And then I have side AB and side FE congruent. So the angle-angle-side theorem says that if any two triangles have two pairs of corresponding angles that are congruent, which we do, A and F, C and D, and if we have one pair of corresponding sides congruent, AB and FE, then without knowing anything else about those two triangles, we can say that they're congruent to each other, so they're two congruent triangles. One of the other theorems we're going to talk about, add this one to your flip book. It's similar to angle-angle-side. It's angle-side-angle. And if you notice, even in the names, the word side is between the two angles. And that's what makes this one unique from angle-angle-side. So if you look at our picture, angle A and angle F are congruent. Angle B and angle E are congruent. And then the side between those pairs of angles, AB and FE, you can see that AB, this marking is between the two angles that I've marked. This marking is between the two angles I've marked. That makes this angle-angle-side. I'm sorry, angle-side-angle. It's a specific type of angle-angle-side. So over here, this is almost exactly the same, except where I said the corresponding sides have to be between the angles. If the corresponding sides are between the angles that are congruent, then this is angle-side-angle. So we're going to look at some pairs of triangles, and we're going to determine if they're congruent by angle-angle-side or angle-side-angle, or if we just don't have enough information to say that they're congruent to each other. Remember that two triangles are congruent if all their sides that correspond and all their angles that correspond are congruent. So in this triangle, this pair of triangles, we have one pair of angles congruent. This pair of angles are congruent. They got two little arcs because they're congruent to each other, but not these two in yellow. And then we have something unique that happens here, and it's that these two triangles share this side here, right where they're sort of sandwiched together. Since that side belongs in both triangles, we can say that it's congruent in each triangle. So here we have two pairs of congruent angles, and we have the side in between those angles congruent. So since that side's between two pairs of angles, we have angle-side-angle. So that means every corresponding piece in this triangle and this triangle are congruent to each other. These triangles are exactly the same size and shape. So that brings up a property that we want to add to the flip book. Whenever two triangles or any two figures, for that case, if they share a side, if they're sort of sandwiched together like this one, we can always say that those sides are congruent to each other in those two different triangles, and what we call that is the reflexive property. So this reflexive property is going to come up time and again, and so it's important to know what it is. It's important to know how to use it, so make sure you add it to your flip book. So let's do another one of these together. Here I can always, when I have vertical angles, and we've been using vertical angles all year, I can mark that they're congruent to each other. I'm going to use two little arcs because I see that I have one pair of angles that's already congruent to each other using one arc. So now I have one pair of angles, two pair of angles, and I have a pair of sides congruent. And notice that this side is not between the two angles that I've marked up. This side is also not between the two angles that I've marked up. So I have angle, angle, side. So these two triangles are congruent, and they're congruent by angle, angle, side. I'm going to do one more with you, and then I'll let you try one on your own. We want to do the same thing here. So in these two triangles, I have one pair of corresponding sides congruent there. I have a second pair of corresponding sides congruent. And then I don't know anything else about these two triangles. There's no more markings. There's nothing else that this picture tells me. So I don't have enough information to say anything about these two triangles. They might be congruent to each other, but I don't have enough information to say that for sure. So you might write NEI or not enough info, something like that. So go ahead and try this one on your own. Pause the video and see if these two triangles are congruent, and if so, which of the two theorems would you use? So again, just like one we did previously, we have vertical angles. So I'm going to mark those with two arcs. So that means I have one pair of angles there that are congruent, a second pair of corresponding angles that are congruent, and I have one pair of sides that are congruent. And notice that this side is not between these two angles. This side is not between these two angles. So that means we can say these are congruent triangles by angle, angle, side. So I have one for you to try here on your own and submit your answer using the Google form, and we'll do some practice and I'll answer questions in class.